So this is deploying and managing SQL Server with dbatools. I am Anthony Nocentino. I'm a consultant and trainer and founder of Nocentino Systems, where I specialize in system architecture and performance. I have my contact information here on the screen. So there's my email and my Twitter handle. Please feel free to reach out to me if you have any questions about today's session. I blog pretty frequently about PowerShell, containers, SQL Server on Linux, and things like that. So check out my blog. And I'm also a Pluralsight author, where I have tons of content on Kubernetes and Azure and Linux. I've been a data platform MVP for the last couple of years, and I wrote a book recently with a very good friend of mine, Ben Weissman, on Azure Arc-enabled data services, which is the reason why I learned Kubernetes. But we're not going to talk about Kubernetes today. We're going to talk about deploying SQL Server with dbatools. And we're going to start off with why it's hard. Like, why is it challenging to deploy SQL Server at scale? Like, if I have to deploy 10 SQL servers or 100 SQL servers, what are the issues that could potentially arise from that? And we'll also talk about the benefits of automation. Well, basically the opposite of the challenges, right? I want to discuss why I want to always deploy SQL Server in an automated way. And then this experience that I'm describing today comes directly from my consulting practice. So this isn't something that I cooked up in a lab. This is actual code that I've run at customer sites that I'm going to walk you through today that I use to deploy SQL Server. But before I got to the point where I was using dbatools, I had to look at other solutions. So we're going to talk about some other ways that you can automatically install SQL Server. And I'm not going to say one's better than the other, but we will talk about why I chose dbatools. And then we'll dig into using dbatools for automated deployment. We'll install a SQL Server together, and then we will configure that SQL Server. And then we will use Pester, which is a testing framework to manage the configuration. So I'm going to jump out 1 second. Can you all just drop in the chat? Everybody can hear me okay? Or raise your hand if you can hear me okay? Just to double. Cool. Everybody see some hands raised. Thank you, team. I just want to double check to make sure everything's good. All right, so let's keep moving forward. Well, actually, I do this when I present this in person. Raise your hand if you have a SQL Server installation checklist, like a spreadsheet or a document that describes how you install SQL Server. See, normally I do this over a Zoom call, and I can't see raised hands, but now I can. All right, a couple, yeah. And then how many of you logged in later to find that the SQL Server deviates from what you've defined in that spreadsheet or Word document, right? That it's just a fact of life for two reasons. One, people change stuff after it goes live. And two, we're human. So if I'm following a checklist, I might miss something. If I have to deploy 10 SQL servers, I might forget a step on a SQL server. And that can be challenging because, we're people. I did it for years. I had server checklists for installations up until I wrote this code. When I realized I needed to be able to install SQL Server the same way, with some customizations, but have a baseline configuration that I wanted to have for my customer sites that I deploy SQL Server at, because I know what a good best practice configuration of SQL Server looks like, and I wanted to be able to repeat that over and over again and minimize my mistakes. Moreover, also adding to the value of being able to deploy quickly, right? I can write code that runs a lot faster than Anthony can go and click through a UI installation. And so I took to Twitter, this was about 6-7 months ago, and I asked the community, I was like, hey, in your environment, do you have automated SQL Server installations? And if so, what are you using? And so the community responded. I got 115 responses, pretty good amount. A lot of community leaders responded to this scientific Twitter poll, right? But 42% have an automated deployment method, and 57% of the community is clicking next, finish in the GUI tools for SQL Server installation, which I thought was, honestly, I thought it'd be the other way. I thought we'd kind of be leaning more towards automation, but still the majority of the folks in the community, well, in this sample size, are deploying SQL Server using the GUI tools. And what was interesting was the tools that people were using. So I have a bit.ly link here. This is in the slide deck. The slide deck has been submitted to the conference site and is also on my GitHub repo, which I have a link to at the end of the deck. But this Twitter feed or thread, lots of folks responded with what they were doing. So there's other technologies that folks are deploying SQL Server with in an automated way as well, like Ansible and things like that. And so this was a great conversation. So check out that bit.ly link here. It'll take you to that Twitter thread. and you can kind of see what other folks in the community are doing. And so let's talk about the challenges. Like, why is deploying SQL Server hard, right? And I kind of touched on this already, is consistency, right? If I want to deploy one SQL Server, 10 SQL Servers, 100 SQL Servers, there's a baseline configuration that I want to do every single time, right? Turn on ad hoc workloads, disable SA, like stuff that I want to make sure that I'm doing in every instance that I deploy, right? Speed. I can only click through a user interface so fast. And I can run PowerShell code a lot faster. That code will also do the same thing over and over and over again. So that's going to lead to consistency. Then there's configuration skew, right? What about when I do roll out and I come back a week or a month later and someone changed something, right? Somebody changed something to the instance to MaxTop1 to fix a problem with the query plan. That's not what we want. I want to be able to measure that when we deploy. And so let's talk about the benefits of automation. Like, number one, repeatable, consistent processes, right? Being able to roll out a SQL Server the same way every single time. Baseline config. Obviously, we'll talk about how to manage. If I do need to make a configuration change for an individual instance, we'll talk about how to manage that. But this is another big one, is speed. The customer site that I cooked up this code at for the first time in 2017 needed me to install 80 SQL servers. And I'm only one person. I can't click through a user interface that fast, but I needed to be able to get these things rolled out consistently and quickly. And I'm like, hey, listen, hey, customer, do you mind if I spend a little bit of the engineering time that we expect for the project to develop an automated solution? And they said, yes, we'd rather have this as code. Go ahead and do that. And so I wrote a process using PowerShell DSC, which we'll talk about in a few minutes, that enabled me to roll that out fast. Because as a single person consultant, if I tried to deploy 80 SQL servers, that would take me a long time. But if I wrote code to do that, that will take me a lot less time. Then in the end, though, we have infrastructure of its code. We have code that can build our environment, which is really powerful for a lot of different reasons. We'll talk about some other benefits of automation in a minute when it comes to like disaster recovery and HA, or high availability. Another benefit is that it reduces human error, and it's kind of lends back to consistency. But I do like to make the joke that it also increases it, because we do have the tools to do things at scale, right? I can run a command against 100 SQL servers using dbatools and break things up pretty quickly in a severe way if I mess things up. So test. And then scale out installations. And we kind of discussed that in the context of speed a few minutes ago, in that I can do things a lot faster at scale in code, right? Because if I'm doing this in a GUI, I can only work on one system at a point in time. So here are some of the lesser known benefits of automation. Measuring configuration skew. If I have code that describes what my system looks like, well, I can come back later and run that code and test, did I skew from that configuration? Did someone change MaxTop to 1? Is cost threshold for parallelism 42 instead of what I want it to be for my environment? And I can test these things over time. High availability, right? You might be thinking, well, how does automation lend itself to high availability? Well, if you have, let's say, a non-aggressive recovery objective, and you can create a virtual machine, install SQL Server, and restore all of your databases within your recovery objective because you have everything scripted out in code, then you don't need to bring in more advanced technologies like failover clusters and availability groups, which raise the technology bar and are more challenging to support than a regular instance of SQL Server. And so if you can confidently go back to the business and say, I can create a VM, restore all the databases, and get you back online in 3 hours or 6 hours or whatever it is, then that's a reasonable recovery pattern, and you don't have to introduce some more complicated technology. Troubleshooting. If all of the systems are the same, and you look at this and you look at an individual instance of SQL Server, and you see, well, this setting's not the right value for what I would normally set as my best practice configurations, and those things surface more quickly in your environment. So when you have consistency in your platforms, if all of the systems are very similar, then you can troubleshoot things more quickly. Moreover, we'll talk about configuring drive paths and drive letters and things like that in a few minutes. Restores will be a lot simpler as well, because you don't have to write complicated restore scripts and deal with move commands and things like that, because You're just going to create a new instance. It'll have the same directory structure. Boom. You can restore your databases with simpler scripts, right? So that all lends itself to simplicity, and I love simplicity because I have other things in my life that are hard. I want to keep this as simple as possible. So when I was working with that customer, I had to go and evaluate some candidate solutions. And we'll talk about a couple that I evaluated specifically for them and some other ones that I learned about in that Twitter poll that the community is using. First off, out of the box for free, you do have a tool to help you with automated installations of SQL Server, and that's the configuration INI. The configuration INI is actually generated when you do a GUI installation of SQL Server, and it has a description of how to install your SQL Server. But that's where it stops. It doesn't help you configure advanced settings in the instance. It doesn't help you configure any operating system level stuff that you might need to configure. Its scope is just the SQL Server installation. Now, PowerShell DSC, or desired state configuration, was the solution I chose first for that customer when I needed to deploy SQL Server at scale. And it's a great solution. It's a good platform for managing configuration inside of an environment. But I found at customer sites that I work with, it kind of raised the technology bar a little too high that most DBAs are able to consume. And so I wanted to have a simpler, more pinpoint solution for installing SQL Server, and that's where dbatools came in. But I'm not trying to knock DSC. DSC is more of a strategy than it is what I needed at customer sites where I just needed to get SQL servers online, right? Versus having something that's going to manage the configuration and state of the Windows boxes in an environment. Scope is a little wider. And so we kind of bumped up against some issues there in organizations. So I wound up pulling back and using just straight PowerShell with dbatools. If your org is using any one of these tools, Chef, Puppet, Ansible, Chocolatey, all of these platforms have the ability to install and configure SQL Server. And so if you do have these tools in your environment, talk with those teams and see how you can leverage the technologies that you already have the in-house expertise to work with. It's like I'm sitting here in a talk telling you to use dbatools, but if you have one of these tools, go with that too. Containers and Kubernetes. I talk a lot about deploying containers and deploying SQL Server in Kubernetes, but that's all on Linux, right? And for my customer base to this day, the majority of it is still on Windows. I need to be able to install and deploy SQL Server on Windows, and that's where dbatools comes in. So dbatools gives me the ability to write code and give it to a customer, and they can just install SQL Server. Similarly, I wrote the code. It's in the GitHub repo. It's in the conference downloads today, and you will have that code available so that you can go and install SQL Server. Now, I will tell you this. Yes, that code is based off of customer sites that I've worked with, but I had to pull a lot of more advanced functionality out. But you have kind of the core that you need to install SQL Server. But I strongly encourage you, don't just run the code. Look at the code and build your own solution for what you need to do. And then you'll find that you can kind of build on more advanced configurations, but it's definitely a great starting point, the code that's available to you. And so let's dig into it. Let's kind of talk about using dbatools for automation. So if you're not familiar with dbatools, let's start there, right? dbatools is a community-driven PowerShell module with the goal of managing, configuring, and deploying SQL Server. The project charter effectively states that anything that you can do inside of SSMS, SQL Server Management Studio, they want to be able to give you that functionality at the command line in PowerShell. In fact, I literally put a tweet out yesterday that I had to write T-SQL for the first time in a long time. And because I'm so used to building and administering SQL servers with PowerShell now, it's my first tool that I use if I need to work with a SQL server. I just write the code because if I need to do it once, chances are I need to do it 10 times or 100 times sometime in the near future. So I'll write that code or whatever solution I have to do for SQL Server and just go pull that from my toolbox later. So when it comes to getting dbatools, how do I get it? It's in the PowerShell gallery. And so you can type at a PowerShell prompt, install module dbatools, and it'll download and install on your local system. It's also available on GitHub. In fact, two things about the fact that dbatools is on GitHub is, number one, it's a very active community. So if you have an issue, post the issue and you'll get a response pretty quickly. Two, the code is there, right? The documentation is great. There's really good examples, but sometimes you just need to dig in and look at what the source code is doing. And I've done that many a time working with various commandlets and functions inside of DBA tools to understand how they solve the problem, or be able to understand like maybe an issue that I'm having inside of the code. Chocolatey is a way to get DBA tools installed. If you're not familiar with Chocolatey, stop what you're doing and go check out Chocolatey. But basically, it's a command line, or excuse me, a package management utility for Windows, where you can install software at the command line. So Choco install DBA tools will get you DBA tools installed amongst hundreds and thousands of other Windows packages. Lots of data centers don't have internet connectivity. Like you can't just go and do an install module and pull something down off the web. So we have the ability to install DBA tools in an offline way, and that's a link there to those steps to do that. Cool. All right, so core DBA tools functionality. Like what can DBA tools do for you? And I'm going to throw this giant list of stuff. So this is what DBA tools can do for you. It's a lot. In fact, these are the categories of stuff that it does. Inside of each one of these categories is a collection of commandlets to do even more discrete things to your SQL servers. Now, the idea is we're not going to go through each and every one of these, but just to give you the surface area of stuff that you can configure inside of SQL Server. For example, you can do installations. You can configure databases. You can configure the SQL Server agent or database mirroring. And so when we get towards the second part of the talk where I talk about configuring SQL Server, after we install it, this is your toolbox, right? These are the things that you can do, right? Configuration of tempdb, SP configure commands. So you'll have all of those things to build your own scripts to get that SQL Server installation to where you need to be. One of the common things when I go into customer sites that they don't have laid out really well is alerts and database mail profiles and things like that can tell us important information about our SQL servers and their lives. And so having code to go and configure that very quickly is super valuable. And so those are the kind of things that we'll do after the fact, after we get SQL Server installed. But this is the toolbox of things that you can do. And so, but we're going to focus the majority of the talk on installing SQL Server and how I install SQL Server at customer sites to make this a repeatable solution that's simple, right, and maintainable. And that's important, especially when you contrast it to other solutions that have infrastructure requirements or kind of change the way that you roll out code. There's one commandlet that we're going to focus on, install DBA instance, and that's the commandlet that installs SQL Server. And the only requirement to install SQL Server on a Windows box is it needs access to the installation source files. So just much like you take the ISO and copy it to a network share and extract the zip or put it on the server itself, we just need to tell install DBA instance where those files are. And that's one of the core things of the infrastructure that we're going to talk about today, and how we can manage multiple versions of having those installation sources for 2012 and 14 and 16 and 17, whatever it is that we need to deploy. So let's get into that. So we're going to start off with the big picture, the solution architecture of how I go into customer sites and deploy a SQL Server. So the first thing that I ask for is an admin desktop. And what I'm going to do on this admin desktop is have all of my tools, VS Code, the PowerShell scripts, whatever I need to manage the environment. And it's going to be in the same data center, hopefully, as the systems that I want to work on. It just depends on the security policy. Most other folks call this a jump box, right? Then we'll have what I call a deploy server. All the deploy server is a file server, just a file server that's usually close to the target installation systems that I want to deploy. Because what I'm going to do is I'm going to put the installation sources on that server. So I'm just going to have a couple of folders for each version of SQL Server that I need to maintain in that environment. In addition to the installation sources on that deploy server, which is just a file server, I'm also going to have the update sources. And what the update sources are is the cumulative updates and service packs for the various versions of SQL Server that I have to deploy. And if you didn't know, what you can do when you deploy a Windows-based SQL Server is on installation, I can slipstream or update the installation at the point in time at which I'm installing. So if I need to deploy 2017 CU17 or some cumulative update, I can basically just say, hey, install 17, but here is the updates that I want you to apply to CU17, and it'll just do that in one install or one shot. It'll get everything up and running and patched. So I don't have to come back later after the base installation is finished and then patch the system. It does it all in one step. Now, in addition to my jump box, right, or the admin server and the deploy server, which is just a file server, I have where I want to install. So we'll call that the installation target. That installation target is just the Windows box or boxes that are the SQL servers that I want to deploy. And so what we'll do on the admin desktop is we'll run some PowerShell that's going to target the remote instance and start the installation process on the installation target. We're going to leverage PowerShell remoting to do this. Now, once that install kicks up, it's going to drag the installation files from the deploy server onto the target. So that's why it's important to put the deploy server and the target in the same data center, or at least over very high speed connectivity, because Windows-based SQL Server installations can be pretty big, right? And we want to make sure that we're removing gigabytes of files and lots of little files potentially between these two systems, that it happens quickly. If you have to do it over a WAN link, it can. It just is going to be slower, right? All right, so let's dive a level deeper now from the architecture into the workflow and how this gets positioned in customer sites that I work with. And so the first thing that we'll do is I'll work with the virtual machine administrators to make a VM template, a virtual machine template that has some very static configurations deployed. So things like my swap file configuration or the drives, all that baseline configuration for Windows I've baked into the VM template, as well as some VM config, like the actual virtual machine configuration itself. And we'll talk about those best practices here in a few minutes. Now, once I have that VM template, I'm going to have those the Windows or the virtual machine admins create however many virtual machines I need from that template. And then once they give me access to that virtual machine, I'm going to have some PowerShell code that runs some pre-flight checks. And what I call pre-flight checks, what they do is make sure that the VMs that I've given to me meet some basic needs, right? Are the drive letters there that I expect to be there? Can I actually authenticate to that virtual machine box? Like things that I want to check before I start the installation to make sure that the installation is going to be successful, right? Or at least not make sure that it's going to be successful, but increase the likelihood of it being successful because some baseline requirements are met, right? Then we'll actually execute the installation. I'll use install DBA instance to install SQL Server, and then we'll come back later with some additional code to configure SQL Server. And so I'll run a bunch of PowerShell DBA tools against the target instance to get that configuration where I want it to be. And then I'll run what I call post-flight checks to make sure that everything that I just did, installation and configuration, actually happened, right? Did MacStop actually get changed? Are the SQL Server agents really there? And check those things to make sure that they're good before I hand that SQL Server off to somebody else that needs to create databases or do whatever it is they need to do. Cool. So let's talk about each one of those steps in a lot more detail, right? So we're going to start with that first step, the VM template. And so with the VM template is I'm going to bake in some very static stuff, things that don't change in an environment, right? And so basically the configuration best practices for the VM itself. And so we'll do things like disable vCPU hot plug. We'll make sure that I'm using power virtualized storage and network adapters. If you're not familiar with those terms, that's okay. I'm going to have a link to the document that describes in detail what these do. But these are very important to the performance of your SQL Server when it runs as a virtual machine. What I'm also going to do is standardize my drive topology such that the volumes, the actual disks, and the folders are basically the same on every SQL Server that I deploy. And whatever the convention is the convention for your environment. So maybe DData, T-logs, S-system, whatever it is for your environment. And we have that be very static because it's just not going to change very often. Now, what we will do is create these drives in the virtual machine template. What I do for customers is I'll have the VM admins create each drive with about like 10 gigs, like not a big drive. And then when they create the VM from that template, then they scale that to the size that's needed. So if you need 1.5 terabytes for data, well, the template doesn't need 1.5 terabytes. When you create the VM, it can scale to 1.5 terabytes or whatever it is per instance. And so you kind of just set a minimum baseline for that volume, that folder configuration, and the sizes as well. And here's where you do something like this, right? The 64K and TFS allocation units for your volumes formatting, right? That way it's something you just set it, forget it, and never think about it again when you move forward. You also can do some base operating system best practices. So you kind of like things like, darn it, what's that thing called? Power plan, right? Obviously we don't want to have the default power plan. We want to use the high performance power plan and things like swap file configuration. So the stuff that's super static, that's never ever going to change, put it in the VM template. Now, when it comes to those more advanced SQL Server best practices for VMware, and this is kind of targeting VMware, check out that link there. That was written by some community members, Alan Hurt and David Klee. That is an official VMware white paper on the best practices. The coolest thing about that white paper is I read it about once every year or two because it's maintained and updated, which is fantastic. And so when I'm working with customer sites, the majority of installations that I work with are VMware based, and I read that document very frequently to make sure that I stay up to date on the best practices. So let's dig into pre-flight checks. The pre-flight checks are a way that we can kind of help guarantee or help increase the level of success that our installation is going to have, like making sure that some base requirements are there. So the first thing that we need to do is make sure that WinRM is there. So WinRM is the ability for PowerShell code to run from one system on another system, on a target system. And so that's what we're going to leverage here from the jump box or our admin server to the target instance. We're going to use WinRM to do that. And it's a function of PowerShell. And so we need to make sure that that is accessible. We're going to make sure that any service accounts that we're going to use for the SQL servers are valid. So we'll check credentials. We'll also have an installation account, which is the account that the install process launches as on the target instance. I want to make sure that those credentials are valid before I even try. I want to test the disk topology, make sure that the drive letters that I'm expecting to be there when I install SQL Server are actually there. Test access to the installation share and also to the update share. Can that target system actually reach the deploy server for the install and updates? So those are the pre-flight checks. Now, what I code the pre-flight checks in is in a PowerShell testing framework called Pester. And we'll use Pester to basically just run some PowerShell and say, hey, server, run this code, and then inspect the result and make sure that the result is valid. Right? So it's a test. Hey, is the D drive there? Yes. Okay. Is the Z drive there? No. Fail. And so that way we can know, leveraging Pester, we can do pre and post configuration checks, right? I can do those pre-flight checks. Hey, the system is in this state. And then I can do the post-flight checks after everything is done. Hey, the system is in this other state where SQL Server is installed and all the configuration tasks have been done. And so we use Pester to do that for pre and post. Now, I can also use Pester to measure configuration skew. So the test that I run for post configuration, well, I can come back a week or a month later and run that same test, see if, well, anything changed. And then I can figure out, well, somebody changed back something one. And I can either change it back, right, by asserting the desired state, or I can go figure out why. Like go talk to folks and be like, hey, why did you change setting X, right? And so I use Pester to do this at customer sites. Now, there is a tool called dbatools that's maintained by some good friends of mine, Rob Sewell. And so what dbatools does is basically what I'm doing in my post-flight checks, kind of some basic best practice configurations. But there is some base infrastructure requirements for dbatools. So I don't use it as a solution at customer sites. I kind of have some Pester code that I maintain that does very similar things. But if you need a longer term solution in your environment for managing the configuration, best practice configurations of your SQL servers over time, check out dbatools. And so let's look at what a pre-flight check is with Pester. We're going to look at some code here together. And so when you write a test, you can group tests together in what are called contexts. And so the first context here is is the server accessible via WinRM? So that's just the name of a grouping of tests. And then there's the actual test, right? And so here you can see I'm using a commandlet test net connection against a computer name. And on the right there, I have common TCP port WinRM. So what that will do is run that PowerShell against that computer and check if that port is accessible and store the result in the variable result. And so that quiet parameter makes that a Boolean value. And so now I'm going to have a test that says the target should be accessible via WinRM, so that's just the name. What we're describing it is the thing that I'm expecting. So we're going to inspect the result. So we see result pipe should be true, right? Because that value in result is a Boolean and it should be true. And we have a because, which is a string that's going to output during the test execution. It says, well, we need to do stuff with WinRM during the installation, right? Yeah, that's in the actual code. We need to do stuff with WinRM during the installation. And that's your first Pester test right there. And what that does is gives me the ability to run, what Pester does is gives me the ability to run code like this against servers so that I can inspect these values, right? So let's look at one more. Service account validation. And so I have a custom function here called test80credential that will take a credential and make sure it's valid. Like, does the username exist? And is the password that I have for the credential valid? And so there we see the parameter credential for engine credential. So in this case, I'm making sure that the service account which we'll run the database engine with is valid. So here we have another test name. So we're testing to see if the service account credential is valid. And then here we see the test for that. So credential result pipe should be true because SQL Server requires a valid engine account. Because I'm sure we've all done it when we've installed SQL Server by hand, where we've messed up that password and the installation halted. The credential is wrong. And so we want to make sure that we have valid credentials before we turn and go and install our SQL Server. And so when we run those tests, this is what it looks like. So this is the output that you'll get from a Pester test. Green is good, red is bad, right? So here we see executing script. There we see the context, the server accessible via WinRM. Target server should be accessible via WinRM. So that test passes because you see it's green. If it was red, we'd see the error or failed, we'd see it red and the error the error that occurred. And that there are other tests we see here. We see service account credential, installation account validation, and then testing for the existing of required drives on target. And so there we see that the drives that are required to successfully deploy a SQL Server, right? So in this case, it's C, D, F, L, S, whatever it is for your environment, right? Cool. So let's look at the next phase. So once we pass those pre-flight checks, it's time to actually install SQL Server. And so we'll use install DBA instance to do that. And I just threw a bunch of code at you, but don't focus so much on the code today. Just we're going to kind of focus on the process, and you can kind of visit the code later. But what we do have in this code is, let me see if I can use my mouse, not use my mouse, is effectively the name of the SQL instance that we're going to install to, where the installation files exist, what version of SQL Server that we're going to install, where we're going to install it, and some basic configurations. So things like data path and log path and backup path. Then some credentialing information, right? So engine credential, agent credential. So those are the service accounts at which those services will start. Installation credential, that's the credential that the install instance starts as. And then some other basic tasks like perform volume maintenance, restart the instance, and verbose equals true because I love output. I love seeing output. But in this scenario, when you first get started, you want to have that on so you can see what's going on. So we're using a technique here called PowerShell splatting. And so all of these parameters get stored in a hash table called installation parameters so that I can more simply call the install DBA instance commandlet with the at installation parameters hash table there, so that it kind of simplifies the code. It just makes it look a little easier to read. And so yeah, I already walked through all of these big bucket items that we have, just some walk through there. And so let's do it. Let's go ahead and run some pre-flight checks and install SQL Server with install DBA instance. Cool. Hi, everybody. I can see you now. All right, let's jump over here. Now, normally I don't video my demos. I usually do them live. This demo takes a little longer than I would like to when I'm presenting. And so I did create a video so that I can jump ahead. And so what we're going to do first is walk through the code together, and then we're going to install the instance. And so this is all on GitHub right now for you, and it's also available in the conference downloads. And what we have is basically some code to set up the environment and some functions. Then we have the installation variables, the things that I'm going to change per instance. And then we have the code that I actually execute. Now, the first part of this code here allows me to use this code in multiple environments. So here we see environment equals lab. And so that environment variable then is used to call in a function called import environment settings minus data center $environment. And so with that code there, what that's going to do is go over here to environment settings, allow me to call other scripts to load settings per site. So for example, DC1 versus lab. Is this running against a data center named DC1, or is this running against my lab, aka my office lab or my customer sites? And so what DC1 will contain is inside this import DC1 environment settings is going to include the settings for a particular customer site or my lab, right? Which could be different domain controllers, different settings for SQL Server. And so what we'll have in here are the settings that are more, they're more stable per customers, per each environment that I need to deploy SQL Server in. So for example, in line 2 there, we see Active Directory domain. We see the drive letters. So customer sites might have different requirements for drive letters. I also here, now you can see how I'm managing the configuration of multiple SQL Server instances. And so I have 2 hash tables here that have keys that are this numeric value of what version of SQL Server I want to deploy. And so you'll see in a moment, when I define which version of SQL Server I want to use, it'll come and index this hash table and then pull out the install path for that. When the install root being the deploy server. So in this case, it's on a server named DC1. If I want to use 2019, I'll index this hash table. If I want to update sources, it'll index that hash table. And that's how I'm able to use or simplify the code so that I can have multiple versions of SQL Server that I want to install. And so on line 9 there, that's where I describe what version I want to install. So I can have 16, 17, 19, whatever it is here. And then I give the SQL instance a name, then what features I want to install. In this case, I'm just installing the engine for this example. We then have some code that sets up the credentials. Again, don't focus on the code. We're going to kind of focus on high level. You can experiment with the code later, but what I'm describing here is the service accounts that I want to run the instance as. Then I'm going to what engine credential and agent credential, and then also the installation credential. And so this installation credential, I'm actually using the get credential commandlet to create that object, the PS credential object that I need for the install. And so at the bottom in a moment, you'll see it just asks me for my password at runtime. I could have hard coded a password in there or used a password manager. In fact, that's a more common technique at customer sites is we'll get this information from password managers. And so you can write that code to do that at that point as well, rather than having it be user interactive or hard coded in your installation file. Now, it's time to run some proliferate checks. And so what we have here in test pre-installation checks is a Pester test. And some of this stuff we walked through in the presentation portion of the talk where I described what a Pester test is. And so there's the first one we have is the server accessible via WinRM? Is the service account accessible? And so this is that code that we walked through in the presentation. That are the baseline things that I want before I even try to install a SQL Server. And so there's a bunch of that code in here. Cool. Go ahead and jump ahead to the actual installation. So yeah, so here's the running Pester test. And so the Pester test is going all green. So I ran 12 tests and 0 failed. We can see at the bottom here. And that ran in 7.25 seconds. So now I know I can move forward to the next part of the test or the next part of the installation. And that's what we're doing on line 33. 3 here is testing, did I get any failures? If there are any failures, right, greater than 0, then break, stop, and let's figure out what happened. Cool. Now, the next part of the installation is the actual install of SQL Server. And so that's what we have on line 41 here. And this is the code that we walked through in the presentation. And so I'm going to take that code, I'm going to highlight it and execute it. Well, I am also going to grab the output of that commandlet and store that result in a variable because I want to inspect that result to make sure that the installation result was successful. If not, I want to figure out why. So while this is running, I'll talk about some troubleshooting techniques about this. And so I have verbose turned on in this output so you can see what's going on behind the scenes. You can turn that off if you need it. If this fails, right, you can get some verbose output is helpful. You'll see some error messages potentially on the screen. But if the install fails, you're going to go and just read the installation log file like you would on a regular install of SQL Server on that target instance, right? Because, well, that's going to describe exactly why it failed. And so it's a super valuable way to troubleshoot that. And so that's what I have in the log message here. It tells you exactly where to look. And so this variable will output where the log file is on the target system. And so what we have here is the SQL Server, the install process is running. And so what I did here is I brought the virtual machine that I'm installing to into the screen here. And that first process there, scenario engine, is the actual installation process on that target instance. So that's going to, if you're impatient like me and you want to know if something really is happening, then if you see scenario engine, SQL Server is being installed. And then a few moments later, what you'll see is once it finishes, we'll see that we get some output from the commandlet. We see that the success is true, restarted as false, where the installer was launched from. So here we see a full path back to the deploy server. And then the log file with the summary of the installation. If that was a failure, you would go look at the same log file location. Now back on the instance, here we can see the SQL agent is running. And if I go down a little bit further, we can see SQL Server is running, the SQL Server process. So with that, let's jump back to the presentation. Pause the video here. Jump back into the presentation. So that's how I install and deploy SQL Server. And I do that over and over again at multiple customer sites. And I'm able to do that consistently and quickly. That entire installation process usually takes like 2 minutes, which is, again, I think amazing. And then being able to do that over and over again is incredibly, incredibly valuable. So in the code downloads, you'll find a function called invoke SQL configure. This is not a dbatools function. This is a function that I wrote that does the post-installation tasks, right? It configures all of the things that I want to have configured on the SQL Server for me. I wrote that code to be what's called idempotent, meaning I can run that script once, it'll configure those settings, but each time it configures, it checks to see if that setting is actually configured before it makes that change. Or the commandlet that I'm using from dbatools does the same thing. It tests to see if whatever is I'm trying to set is already set. And if it is set, then it doesn't do anything. And if it needs to be set, then it'll set it, right? It's going to change that configuration. But the idea is I can run it over and over again on an instance without breaking anything, keeping things in the configured state that I want them to be in. And so let's look at some code inside of invoke SQL configure. And so inside there, I have a collection of functions, right? And so here's one function that does some stuff. That what this does is this calls, it's a function that I wrote that calls, it's called disable SA login, that will go and disable the SA login. And so lower down in the code here, we can see I'm using the dbatools commandlet, get dba login, and then I'm piping that into another commandlet, set dba login. And so in the code that we're going to look at momentarily, you're going to see this pattern where I have a collection of functions that do work against the SQL Server to configure it. And then I also have a collection of discrete dbatools commandlets, the ones that might not have to have logic like this one. So you'll see a bunch of functions that do a bunch of work. And then you'll see a bunch of discrete dbatools commandlets that also do some work. that execute against the target instance. And so let's go ahead and dive into that code. All right, so inside of invoke SQL configure, you can see some of the tasks that I'm performing, right? So first up is configure page file. And so in this case, I'm setting the actual Windows swap file. This is something that you could put in your virtual machine image if you want to. That's a common place to put that, but here's some example code to do that here. Go down a little bit further in this code, we'll see that I have other things that do things like add a group to the local administrators group on a target instance. So for example, like if your database group is allowed to have local administrator access to the SQL servers that it manages, well, this is the configuration that's probably important to you to make sure that you actually are in the local administrator group. Then we also have the ability to create logins. There's disable login, which we just checked in the presentation. And then I have some code here on line 64 that talks about trace flags that we want to have configured. So again, anything that I want to have configured for a SQL server, I'm going to have defined in this block of code here. Let's scroll back a little bit. We can see I have set SP configure options. So I have a collection of SP configure options that I want to have configured. So there we see the DAC is enabled, remote admin connections, optimized for ad hoc workloads, database mail is turned on, a baseline configuration for cross threshold for parallelism. Anything that I want to have configured is in here. Then I will use that against the instance. So what we're defining in the top of this file here are the functions that might have some additional logic to them. And then I call them later at the bottom of the file with a collection of files that might not have any additional logic with them. So for example, set DBA power plan. I don't really need to have a test and set for that. I can just set it. And so that's why you see a collection of those commandlets here too. So we have power plan, max stop, max memory, tempdb. I'm accepting the default configurations for those. Tempdb does allow me to parameterize some more advanced configurations, so I'm doing that there. And now we can see my custom functions, disable login, configure trace flags that have some additional logic are being called here at the bottom of the file. So I'm defining them at the top and calling them at the bottom. And then when I call invoke SQL configure, 20, 30 seconds later, all that stuff is done, right? And so I can use that script to make sure that every SQL server that I'm deploying has that baseline configuration. If I need to deviate from that, then I can write code specific for that customer or for that instance, and then take that and park that in source control and maintain that configuration over time. So that is how we install SQL Server. Excuse me, configure SQL Server. And then finally, I have some code that's going to do some post-installation checks. So let me jump back into presentation before we get into the post-installation checks. So the post-installation checks is a broader Pester test than the pre-installation checks, but the process is, the code is the same. And so I'm going to check for things like, are services started? Is the engine running? Is the agent running? Are the accounts that I added actually added? Are the accounts that I want it disabled actually disabled? Is my SPN configuration stable? How many of us got burned by that in production 2 or 3 weeks into a rollout, right? Let's get that stuff earlier on in the deployment process. Instance setting, so max stop, cost threshold, anything that I want to set. This one is a big deal and I love having this. Agent settings, database mail, are alerts configured, are the basic jobs that I need deployed, backups, index maintenance, if that's your thing. All of that stuff can be tested here so that is it really actually there in the production system or the soon to be production system. Database settings. One of the things that I have in the Pester test is to configure model, right? So model database so that it has some baseline configuration. So when somebody does create a database, that it's got, more modern settings for the defaults than what we have in model database. And any sort of procedures that I want. So if I want to have who is active, or if I want to have Ola Hallengren scripts, or if I want to have the Brent Ozar first responders kit, all of that stuff can be installed and I want to have tests to make sure that it's actually there. And so when I come back later and I run the tests, well, I have tests that go and test those configurations. Is the SQL agent configured, right? Is it up and running? Are there operators set? Another big one for me is, do I have the appropriate job history link for the agent so that I come back later and see job history? Sometimes you'll have customers that run jobs very frequently and your history will roll off and you don't have any intelligence about what actually ran. And so this is a way to make sure that I have that when I come back later. And at the bottom here, we can see I have some tests to make sure that are the stored procedures that I want on the instance there. So Ola Hallengren script, who is active, so on. So let's go ahead and run some Pester tests to check our configuration. Cool. So what we have here is I'm inside the test post installation checks files, and we can see I have some tests. So there is my SQL Server agent configuration. Now here I'm starting to use more dbatools commandlets, where in the first test I didn't have SQL Server installed. So those are more Windows commandlets, dealing with the actual server itself. But here, again, anything that I changed and configured, there's going to be an analogous dbatools commandlet to make sure that that thing that I changed and configured is actually done. So here we see on line 28 in the test, get DBA service, right? Get its state, make sure that it's running. And so we saw in the previous test, a lot of those are Booleans. Is this thing there or not? Yes or no? Well, here I'm checking the actual state, right? I'm doing a string comparison to see, is it actually running? Well, because we want to ensure SQL Server is online. I also have SQL agent operator check. So on line 32 here, I have it making sure that there is an operator named alerts. So this is a little bit more of an advanced check. There's two tests in this one. So is the operator there? And does it have a valid email address, right? Because I want to emit alerts from the operator. Next up is the agent history. So again, I'm using dbatools commandlets to pull this information out and to check that over our instance. Going down a little bit further, there is our database mail configuration. Again, I'm kind of going through the code very quickly, but I want you to focus on the process right now, not the code. The code will be available for you to download. Ola Hallengren scripts and so on. Somehow a code comment slept. Oh yeah, I remember that. Number line 70 there. I actually left this in on purpose. The get DBA DB stored procedure commandlet is really, really slow. And so we want to use this other method on line 71 to get that data out. Thank you, Chrissy Lemaire, for helping with that. So that is our post-installation check. Here we see, are the jobs there? So is there an index integrity, or is there a database integrity job for a system? Is there an integrity job for user databases? Those are all part of Ola Hallengren scripts, and I want to make sure that these things are there before the system goes into production. Now on line 106 here, I have a little bit different a code. If I come back later and I want to run this code a week later against an instance, and to see are the things that I've set still set, right? And that's what this will allow me to do. But what I'm doing here is to test to see if the maintenance jobs have actually been running. So if I come back a week later, well, did backups really run? Did index maintenance run? And so this is a Pester test that will look at the job history to see if those things actually occurred. And so that's a way for me to make sure that the things that I want to have running against the instance are there too. So you can use that, again, for some more advanced checks. I'm just checking job agent history, but you can check other values that are exposed to you via PowerShell. And so on the bottom here, it's going through all the different checks that I've defined. And in a minute, we'll see green. So 39 tests were defined, 39 passed, 0 failed. And so I can have a pretty high level of confidence now when I give this SQL Server to a customer that it's in a well-known state. And I can do this over and over and over again. And this entire process might take me like 3 minutes. And so I can have, from getting that virtual machine to installing SQL Server, configuring it, to testing it, is about 3 or 4 minutes for a Windows box, which I think is pretty awesome. Well, cool. So we're kind of coming in on the end. We've got about 5 minutes left. So let's do a quick review. We learned how to deploy and manage SQL Server with DBA tools. We talked about why deployment is hard, right? Long story short is we're humans and we make mistakes. We have to do things at scale, and we can't do things as fast as a computer can. So we learned about the benefits of that, automation, speed, and then kind of the unknown benefits of that. I can go back to my business and say, I can build a SQL Server in 3 to 5 minutes, and I can that's infrastructure dependent, by the way. Your infrastructure has to support that level of speed. But in my experience, it's about 3 to 5 minutes. I can then get my SQL Server online and restore my databases however long it takes me to restore. And that might be better than a failover cluster or an availability group because it's simpler. It's simpler maintained in the end. And then we looked at some automation solutions to things like DSC, and we discussed Chocolate and Ansible. If you're using those in your environment, check those out. But we focused primarily on using DBA tools for automated deployment and using the install DBA instance commandlet to install SQL Server. And then the custom function that I wrote, invoke SQL configure, that will then configure that SQL Server for you. And so you can build these systems to do that, to get your SQL servers up, running, and configured for you quickly. And then how to use Pester to manage that configuration, leveraging that testing framework to make sure that what you did actually got done, right? Is SQL Server running? Is the agent running? Is there an operator there? Those kind of important metrics or important configuration points in your platform. Now, I'm going to throw a shout out to the DBA tools community. I didn't come up with any of this. In fact, the DBA tools team built all of this stuff. Like the DBA tools part, the code that you saw is stuff that I wrote. But the idea here is I'm standing on the shoulders of giants. These folks are the community leaders that founded and built DBA tools and made it what it is. So Chrissy is the primary founder, and Rob, huge evangelist and code writer. Kirill is the actual writer of the install DBA tools commandlet. So that is his commandlet. I thank him so super much for that. Jess, who's a big proponent of using PowerShell DSC, is also, so go out, if you want to see how DSC works, check out her community presentations on that. She's blogged about it a bunch. She's also a maintainer of DBA tools. Claudia, Sander, and Stuart, thank you all so much. And the huge community that supports this project. The DBA tools project is such a huge thing that I think it's literally changing the way that data professionals administer and deploy systems. So thank you so much. They have a book that talks about basically how to be an enterprise DBA using DBA tools and PowerShell. It changed my life and how I manage systems, and I strongly encourage you to check out that book. If you have any questions or comments, please feel free to reach out to me or the conference themselves. Thank you so much for having me. This presentation is currently on GitHub at that location there. If you want to get access to that, the code is also there, and it's been given to the conference for download. So we have about, 2 minutes left? So maybe we can kind of open it up for questions if there's any questions or comments. So there's a question in the chat. Is it possible to copy all permissions from one account to another? Permissions. I haven't messed with permissions yet, but I'm certain that there is. Let me still sharing my screen because you can see me walking around. How do I get off of that? Let's go here. When it comes to DBA tools, this is my go-to place. So if you go to this location here on the web, and let's see, permissions, grant and revoke. No, that's on G's. I'm sure there is a way to sync DBA login permission, copies permissions from one server to another. So that would be, and you can do it for an individual login. So that's what you just saw. When I want to figure out how to do something in DBA tools, that's the process that I go through. Is I literally go to that website, I look at the functions. Oh, that one looks good, and then I go and I start building what I need to build with whatever tool that is. Because the idea is anything that can happen inside of SSMS is available to you inside of DBA tools. So, all right. Are there any other questions? I don't know how to do not in the chat, so that's kind of why I'm doing one. Oh, thank you, Peter. All right. What is the minimum version of PowerShell that DBA tools works with? I haven't I talked with Christy about this recently. I think it's down to 3. They don't want to support 2 because there's some security issues in 2. But on any modern version of PowerShell, I haven't had any issue. So I know at least everything that I've installed has been 20 on Windows 2012 or greater, primarily 16 and some 19. And so with Windows PowerShell, not PowerShell Core, Windows PowerShell, you'll get 4 or 5. It's tied to the version of the OS. So if you're deploying a modern OS, you're going to get a modern version of PowerShell. So good question. Question number 2 is installing SQL Server with the CU and SP together. What if the installer decides it needs to reboot? So we do have the ability to say, go ahead and reboot the server, install, restart as the parameter. So it'll just go do it. Now, if in practice, I haven't had that be an issue. So if I get a box, it's not going to have a pending reboot usually already. But you're right. Honestly, I should probably have a test in there to see if there's a pending reboot before. That should be part of the pre-installation checks. In fact, check for pending reboot in pre-installation checks. Keep myself as a note for that, because that, that's super important, because we don't want to start that installation process if there's a pending reboot, because that'll cause you grief. Do you have a ready function to synchronize? They do. I don't use it though. Sync, I think it's called sync availability group. Yeah, syncs dependent objects, jobs, logins, custom errors for AGs. And so any of these things, it'll sync to logins and permissions, right? Sync between AG nodes. The chance, if it's probably going to do SIDS. I haven't worked with this code directly, but I trust the team enough. I would test it, of course, but I trust the team enough that it's gonna do the right thing with regard to SIDS for logins. I don't use that code because I just, for some reason, I've always been cautious about automatically syncing objects between systems. So I haven't worked with that directly. I'll write the discrete code saying, copy these logins, copy these jobs. That's my own paranoia. So it's not anything against the commandlet.
Thanks a bunch.
Cool, thank you. How did we get off mic? That's cool. Cool. All right, well, I'll hang out for another minute or two if there's any more questions, but I do appreciate y'all coming, so thank you so much. Well, cool. I'm going to call it a day, team. I'll leave my contact information here if you want to reach out, but thank you so much for attending. I really appreciate the opportunity to speak. So thank you so much.